Okay, everyone, so last time I drew some pictures and I kept on drawing these arrows and saying, these arrows are forces because everything in life is going to be having a forces applied to it. But what is force? Well, first off, a force is a vector. That's a big detail here. What that simply means is that if I draw it, it's going to be an arrow. And the second thing it means is that a force has a magnitude, which is the length of that arrow, and a direction. So if somebody asks you how much you weigh, you don't just say weigh. No, you give them a number. Okay, you give them a number. That's the magnitude. And the direction, well, with weight, it's going to be pointing down. Nobody has negative weight. They're not just like floating in the air. So that would be super cool. So forces and the effect of forces. First off, what is a force? Well, it's a push or pull exerted on one body by another. There's always something causing it. Even if it's a non-contact force like gravity, there is a big body which is causing that force. Now, what effects do forces have on bodies? They can cause a body to move if it's at rest, or to change its motion if it's already moving. They might also cause it to deform, to bend, to snap, to break. And sometimes they don't do anything. They just cause internal forces inside the object that end up canceling it out. That's like with the case of friction. If I have friction acting in a box, even if I push on it very lightly, there's going to be frictional force which resists me, so I won't even see anything happen. In statics, we do not concern ourselves with the deformation of the body. We'll get there. That's when we get to strength of materials, the second half of this course. We do concern ourselves with bodies at rest, or moving with zero acceleration. They can be moving as long as they don't change how fast they're moving. Now, these kind of bodies are considered to be in equilibrium. If they are out of equilibrium, then they begin to accelerate. And that's not something we're going to worry about. So if we wanted to, then we could say the effect of a force in statics is the tendency to preserve or upset equilibrium. Like friction right here, it's preserving equilibrium. It's keeping this box from moving even though I started applying a force on it. If I start trying to squish the box, well, then the ground is pushing back and is once again preserving equilibrium. So this one is trying to disturb it. This one is trying to preserve it. What are some characteristics of a force? Well, first off, magnitude. You have to know how much force it is. That's usually a number. So a 1,000-pound force has a larger magnitude than a 500-pound force. And sometimes it's graphically shown by the length of the arrow. I will very rarely, if ever, do that in this course once we get past breaking things into components. I don't usually draw things to scale. But I could if I wanted to say, well, that's 500 and this is 1,000 because it's twice as long. And it used to be that is how problems were solved. They didn't have fancy calculators or computers, so they would literally draw lines that were a certain length, and they would see okay, well, I know that line is that long, maybe 4 inches, whatever it is, and I know that this line is going to be 5 inches long. I have to connect those two. And so they would just draw it and then measure with a ruler. That is how science used to be done, and it's amazing that we've managed to get to the moon and do so much incredible stuff with just that. Now, direction is the second thing that it has. Magnitude and direction. I don't just know the number, I also know what direction it is going. It's going that way, it's going that way, it's going that way. The arrow points in a particular direction. Then sense. Now, for all these, the force is acting along a line of action. I have my force, and the line of action is just if I were to draw a line through my force vector, this little arrow, and go off to infinity in both directions. That's the line of action that it's doing. But what direction am I going? Am I going to the right on that line or the left on that line? Well, that's fairly easy to see here because I have put a little arrowhead on it. But if I make mistakes, this might mean if I said, let's say this was supposed to be negative 500 and I wrote it this way, well, maybe I should just spin it around and say that it's pointing that direction and make it positive 500. So since it's going to be that negative or positive sign, okay, it's just going to depend on what direction you draw it and what you've decided is the negative or positive direction. Finally, point of application. This refers to the point or in some cases the area on which a force is applied. Okay, This is going to be where the arrowhead contacts the body or the point where it originates from the body. So if I have this long bar, this will be the point of origin. If I have a second force, that it points from here. I can't just move that force willy-nilly and say, oh, it's down here now. That would change how the body is actually being affected. Some situations it wouldn't matter. There's many where it would. Okay, so we'll stop here today and then we'll continue talking about forces next time. So thank you for listening. I'll see you all then. Bye-bye.